Hi everyone, welcome to my presentation about a new approach to do data warehouse data loading. And my name is David Zhu. I am experienced database administrator and data architect, and for many platforms I have been working in the past 15 to 20 years. Such as SQL Server, Oracle, DB2, and recently I am a ELT foundation architect for IBM Netezza. So what an average EDW looks like. So look at the chart on the screen here. On the left side, we have a landing folder, store many source files. So that represents where the data warehouse getting their data from. And the first stage of the data moving into the data warehouse is, we call it level 1. The data was modeled as a source view. So whatever the source in the file looks like, very likely they are identical or similar in the data warehouse, except it's stored in a different physical location. Or this is likely a relational database. And for level 2, we would like to move the data from level 1 into a conformed model. Then to really get the value out of this data warehouse, you want this data to be used as a report. So that in that case, we are likely move the data from both level 1 and level 2. Most of the time it should be level 2, but there's exceptions, right? So when the data move into level 3, now you can make the data exposed like views and material like tables, which get the better performance. Now the business user can actually utilize them. Now let's talk about our new approach, which we call SQL ELT. So the difference with traditional tool-based ELT or ETL, first of all, of course, their target is the same. You're trying to move the data into the EDW or inside the EDW. And in most of the scenarios, the ETL process itself is a batch process. So what drives the tool-based ETL is ETL applications. There's lots of them in the market. And in most of the scenario, the ETL application are running in a separate hardware and the software. But in our new approach, SQL-based ELT, it's the SQL statement actually run inside the EDW hardware. So you don't need to invest new hardware. And in our POC scenario, we're actually running the application in a very basic laptop, Windows 7 Home Edition. Investment. When it comes to the money, the ETL application will charge you quite a dear amount. Let's say you need to pay for license, you need to pay for the ETL servers, and you need a special trained people who can use this ETL application and also doing the development. But comparing with SQL-based ELT, you only need developers who know SQL statements, which is quite generic, right? So, for example, if you compare DB2 SQL, Netezza SQL, or Oracle SQL, they are quite similar. When it comes to the performance, let's say, because you have expanded your data warehouse hardware into your ETL hardware and bound them together so they become one ecosystem. So the best performance is whoever performs the weakest, right? For example, if you data warehouse is MPP system such as Netezza, it performs quite well in itself, and you put a pretty weak ETL application trying to hook it up with the data warehouse to make it the one single system, then very likely become a drag, that ETL application. So compared with SQL-based ELT, we are running the SQL statement inside the EDW. So it's the pure dependency is the EDW itself. So why is that? So if your EDW are very good hardware, very likely, because when you purchase such hardware, you put your SQL performance in a very high priority. So you won't buy something, say, running a simple join statement and takes forever. That's not going to be your buying point. So conclusion, we will likely see SQL-based ELT actually perform much better than the ETL tools. So if you're working in the data warehouse area, so some of the functions is likely also your focus points, like data lineage tracking, metadata awareness. So lots of ETL vendors are boasting that they can achieve that with their tools. But with my experience, I would say most of them are very disappointing. The only thing which I prefer or we see it's better with these tools is they do provide graphic user interface for users to mapping the source files into their target tables. That's one of the advantage. So when it comes to design our SQL ELT framework, data lineage tracking and metadata awareness actually is also achievable by SQL-based ELT. The complexity depends on how complex you design it. So with much work, let's say we want to do this demo to show how we can easily achieve a SQL-based ELT. So what you see now is our main interface for SQL ELT. It's a web interface with combining the job monitor, like a reporting, and the job configuration into one application here. So the first interface you see here is for job monitors to see which job you're running, the different status of them, failed, running, and what successfully committed into the data warehouse. And there is comparison of how many records have been inserted into data warehouse and what's the general average performance, what's the total size of the file they have been processed. And if you expand this table for all the successful ELT batch process, you can click the audit ID, and we can actually see each individual SQL statement has been processed in this batch process. So each statement will give you a statistic of how many seconds it's been used to load this data to run the SQL statement. And this is the data associated with the source file, what's the file size, and what's the file date itself. Okay, so now if we move to job configuration. Okay, so this screen is a start point where we see how many SQL ELT jobs has been configured in my system. So let's say I want to add a new job, and we would choose a single input file. Okay, so now we fill up all the parameters we needed for the job. The target table, the source file type, and where you search this source file, and what's the file pattern you should match. So let's confirm. Now it comes up to the 3 components needed for the job. So you will need your main SQL. So what this main SQL looks like? Let's say, let me go to my source folder, and I'm going to show you the SQL statement here. So this SQL script was developed for IBM Netezza system. It's using the set catalog to point your database to which working area. For example, in this case, we're creating an intake table, and we use Netezza external table SQL statement and trying to load the source file from landing zone into the intake table. And from intake table, we can do data validation and further process by moving the data into a staging database. Then eventually, we will move this data into level 1 DB and in the target table. And when the main process finish loading the data, we can do some cleanup by using also the SQL statement we call the post process, by either saving the process data into a central location for data lineage purpose, or in our case, we're actually doing some SCD, so change data capture. So we want that change data capture being saved in a single location for next time another SCD come in to compare for. So now if I say confirm this loading, so the SQL statement which we seen in the file has been loaded into our job system. And now if I go back to the new job, and we're going to update the post process, and we said override. And that's the first one is our main process, the second one is our post process. Now, if you pay a little bit attention to the SQL statement we have shown you, you'll notice there's lots of SQL parameters actually inside the script. So why is that? So what's the value of those SQL parameters? Now you are seeing them. So the reason you use parameterized SQL statement is trying to increase the value of the single SQL statement. You want to reuse them. So that's general terminology for object-oriented programming. So what's the purpose? You do OO programming. A programmer said my programming can be reused in different platforms. So same idea. We want the SQL statement can be reused for all kinds of source files, even though they have different structure, but we want to use same approach. So now you notice there's parameters which indicate where I get my Netezza connection, which this is the default system value. We have the same default value for SMTP server for the job notification. Then we have a notification email. We have what's a default intake DB and staging DB, and what's my default target DB. Now we come to see some job specific values for the SQL statement here. So landing zone, what's my schema, and such and such. So when this is configured, now we actually have this job ready to run. So if I click, say, menu run, okay. So now you're seeing the screen clear with all the tag and the hyperlink available for us. So if I click refresh to see, okay, so our new job is 1009 as a job ID. So if I click menu run, so it's showing me right now we have a test file sitting in the landing zone waiting for the process. So if I say, okay, that's true, let's start a job. Okay, we have a job ID created for this process. Now we can move on into the monitor screen to see how the job is doing. So it is running, and this is the link to show us how the job being processed. So this is not a very big file. It's only a 1 GB file, and it took about 20 minutes to run in an emulator environment. But to see the real power of this SQL process, we're going to demonstrate a little bit bigger file, which is 11 GB. So let's hand on to the demo.